Unit 4 Chemistry, Chapter 17. Looking now at how much energy is in these foods. Last chapter, nearly done with the course. Well done, you guys. So, if we think about our main energy storing molecules, carbohydrates, triglycerides, and proteins, okay? Fats have got the most energy per gram, okay? So per gram of fats or oils, you've got around about 37 kilojoules of energy, as opposed to carbohydrates and proteins, which are both on around about 17. Okay? If we look at the heat of combustion, we'll see that actually the energy from fats and oils is even higher, and same from proteins. Okay? That's because not all the energy that's in them can be used for the body. Carbohydrates are the ones that we are most efficient at using. We can use basically all the energy within them. Amino acids are really useful. We use them to build protein, so we'd very rarely break them down to make energy. But if you get into a starvation situation, then obviously anything goes, and keeping the body alive is more important than building new tissues, which is why you get muscle wastage when people have not got enough food, because they're going to be wasting away those muscles in order to keep them alive. We can calculate the energy value of food by looking at the percentage composition, and therefore adding up the total amount of energy in it. So if you've got a sample of white bread, and we know that it's 53% carb, 8% protein, 4% fat, and the rest is water. The water isn't providing any energy, so we can forget about that. The carbohydrates, we will take the percentage, multiply it by the energy per gram. Okay, so this is how much we'd have if we have 1 gram. We'd have 0.53 grams of carb. We'd have that amount of energy from the protein and that from the fats. So add them all together, that gives us our total energy per gram from this particular slice of white bread. Okay. If we look at some common foods, we can see that things like nuts are very energy dense, lots of energy per gram, and that's because they have a large amount of fats and oils. Whereas things which are containing lots of water, and therefore you'll see these percentages don't add up to anywhere near 100, they're going to have a smaller amount of energy, because of course the water is not providing much at all. Okay. Those foods within your body are broken down to provide energy for cellular respiration. Okay, so cellular respiration is the breakdown predominantly of glucose to make a molecule called ATP, adenine triphosphate. Say that again 3 times quickly. The adenine triphosphate is what is used to build up molecules or for any other reaction in your cell. So it might be used to link together amino acids to make new proteins, for instance. This reaction is the exact opposite of photosynthesis. It is, of course, enzyme catalyzed, and it has a very large delta H value, okay, 2,800 kilojoules per mole.